What if you share your picture also, sir? Your video, sir. Sir, kindly unmute your mic, please. We are not listening to you, sir. Dr. Niaz, thumbs up. We are not listening to you, sir. Your mic is mute, sir.
Unmuting is in process, please. So can you listen?
No, it is okay, sir.
Okay, sir.
But unfortunately, your screen is not share. Your
Now
presentation screen.
let me go to screen.
Okay, kindly. And also kindly also share your camera, sir, for your picture.
Okay. Faraz, today too, you are my teacher because this is my first time to do all these things myself.
No issue, sir. It's a normal.
Okay. So let me come to the presentation. So first of all, I was talking about the three keywords: sustainable water management and water conservation technologies. Let me give you a little definition about sustainable water management. Sustainable water management means the ability to meet the water needs of the present and future generations. Very clear, simple words. Present and future generation is a big question for us. What we have today and what we are going to leave for our coming generation. Second, water sustainability. It means effective and holistic management of water resources, which I will be, inshallah, going to explain to you. In next slide, I wanted to give you background about the water resources of Pakistan. The main water resources in Pakistan are number one, rainfall, number two, groundwater, and number three, surface water resource. In rainfall, we have 32 BCM water. First question comes that how much we are using this 32 BCM water effectively, because we are talking about the sustainable effective way of using water. So effectively mean we are using only 10 to 20% water effectively. And about a few days back, I was talking to my senior colleague, and he was telling me that two days people are talking about, especially the who are working with water, they're talking about green water, blue water, gray water, and black water. So green water is probably that water which we are going to harvest directly from the rainwater. Blue water, which is part of runoff, gray water, which is just mixed with our sewage water, and the black water is the very worst part of our used water. So we are interested to talk about green water and blue water. Next is our resources, groundwater. Exploitation of groundwater is about 59 BCM. Over 1 million private wells are sucking this water. 40% of total water at farm gate. These are the questions where I would be again discussing in next slides. Now, surface water resource mostly coming from slow glaciers. That's enough and good amount of water, that 171 BCM. And now here question is that out of this 171 BCM, Tabela, Mangla, canals, water courses. No doubt we are doing a lot about this, and I will be talking but very little about this part because all the nation, all the water management people are working for this one. My more concentration will be about the water productivity using water conservation technologies. Here in this slide, another threat, which is population growth. So in the first definition, I said that today water and tomorrow water. So tomorrow water, you can see there's a big threat as a country, as a nation, and we have to be very, very careful. Regarding our water resources, in the last slide, we came to know that there's rainfall, glacier water, and groundwater. No doubt groundwater is dependent to rainwater and the glacier water. So these three we have to manage. We cannot increase, as has been said by the director center, that these are the resources. We cannot increase, but the only thing what we can do is the management and sustainable. Next, please. So here a picture of a great picture of water shortage in Pakistan. I don't want to discuss much because we are from the same discipline. Most of us know a lot about the water shortage in Pakistan, and especially the area of Balochistan, Sindh, even in Punjab, they are water shortage area of Pakistan. Next, please. Now we have to look at the consumption of water in Pakistan. So if we look in the consumption, agriculture is number one. About 70% water is going to agriculture. So we have to think about how to use water for agriculture, keeping this point in mind that we have to increase crop water productivity. Crop water productivity is a question because we cannot increase our land resource. Probably there is place for land resource, but water are the question. So here is the global future water scenario. So we are not only one country who is working about sustainability of water resources, but it is all over the global that water is getting shortage. The reason is the increasing population all over the world. Existing situation of Pakistan, water is becoming scarce with each passing day. Very clear. I think there's no doubt. All of we are well aware of this issue. Secondly, efficient irrigation water is the efficient use of irrigation water is the only sustainable option left with us. Here we mean that there's big losses in the system, and we have to improve those losses. And that is the sustainable option left with us. Probably, yes, this is the option we have been working about that. But today I will share with you there are other options, and the country, those countries which are facing water shortage, they are working hard to go about the water productivity in different forms. Purpose of water and its productivity mean we are interested to address our food. So when you say the sustainable option is irrigation water efficiency, the first thing is that we are talking about our food. Today need of food and future need of food. So this I will be discussing in coming slide, please. Another way to open the eyes of professional working in the area of water for agriculture. Here you can see this was one of my student study for the body job, and you can see that storage, recharge, and pumped water or dual waters or wells water. So there is a gap. If there's gap, it means groundwater is depleting day by day. Another slide shows that supply, demand, and deficit, Rabi, Kharif, and total. Look in the total. There the supply is only 30, demand is 133. This is without rainfall, please keep in mind. If there is rain, good rains mean they're contributing and they're addressing the figure of supply and demand. But if there's no rain, there is a kind of drought situation, then this is the scenario. And in this scenario, we have to see that we need to meet 102 for the present cropping intensity. And when we are talking about to increase the food for the increasing population, then it's a big question. Now, emerging threat about situation is rainfall distribution. Under increasing temperature, rainfall distribution has been disturbed. There was no rainfall in Balochistan or little rainfall in some area, but now it is increasing. Every day we watch TV that there's rainfall in Karachi, there's rainfall in Karachi, there's storm in Karachi, there's storm in the Balochistan. Whereas no doubt we are having a good amount of rainfall in Punjab, but this is happening under the temperature increase and the climate change. Water conservation. So our today topic is how to conserve water. So water conservation, we need policy which is at the government level, strategies at our what I say, the members, selected elected members, and then strategies with the professionals. Activity especially is with the technocrats, people like working in the profession. So we are the people who have to go for activities. And tasks under these activities include protect water environment, address current and future water demands. This is what we need for conserving water. Water conservation technologies. There's a big list of water conservation technologies. But I will share which belong to us, which is our need. And we can do it very easily. We are doing it. But I will give you some of my work. I, being a farmer, being a agriculture engineer, being a hydrologist, and son of soil, I thought that what we need, that is number one, rainwater harvesting. As has been said by my colleague, that we cannot increase water, we cannot produce water. There is only that we have to use water very useful way and with high productivity. This is the question. Whether it's rainwater or it's river water or it's canal water, we need. It's the only that we have to be very careful. For example, here I wanted to talk about the laser land leveling. Laser land leveling is very important for increasing crop water productivity. It not only saves water, it not only increase crop, it is really a need of our irrigation methods. It's a need of our crop water productivity, better crop water productivity. Question I wanted to share with you is that here concern is that I have been working with laser land leveling part with Director General Mustaqil Saab and his team and others. It took almost 30 years. Now farmers are after the laser land levelers. Every farmer, smaller or bigger, is looking laser land leveler. If it is really a useful technology, why we have wasted time? Why it has not been adopted at the very early stage? Now it is happening. Same I wanted to give that what I'm going to present you. If you accept it, it must be accepted as the earliest and before going in the food hungry nation. Because we are the very safe country, very safe country. The reason is only the food is very, very cheap. Two things are required in this regard: food quality and food quantity for the increasing population. Let me go for the technologies we need today to increase our water reserves. I say water reserves. The number one water reserve is groundwater. If we look back 30 or 40 years, there was very safe groundwater quality. And now, very bad. I'm next to Rawalpindi. My village is very close. And I had a very potable water, very good quality water, drinking water by hand pumps. Now we cannot even touch it. A big question is quality. If we cannot do it or treat it in our urban areas before it becomes a part of our groundwater or our surface water, then at least we need to mix it with the groundwater, the rainwater, to dilute it at some level that our every next person is facing a lot of waterborne diseases. Every village, oh my God, you cannot imagine. I have requested my son, who is American national. He was working back in USA as a doctor. I have opened hospital and requested him to come back and serve his own people. He is thankful to Dr. Shah that he has joined us in my village, and we are running one hospital about a month back. And that is the main reason for the public health is the groundwater quality. Now, how we can address this groundwater quality? Second is, there's a lot of water which is being wasted in our rivers, in our canals, no doubt. We are working about at micro level, which is the on-farm water management. A good teams, a good number of colleagues are working on-farm water management, and they're doing very good job. But question is that if we want to really increase our water resource, that is by storage, groundwater storage or surface storage. And no doubt, the very, very economical way of storing water is the groundwater. And I will be sharing this, that how the other nation facing water shortage is working on this issue. Solution for groundwater recharge, in my view, I put these three options here. In-house recharge, on-farm recharge, conversion of open drains to weir controlled drains, river controlled drain, recharge. In-house recharge, our population is increasing. You have seen in the second or third slide that population going vertically up. And what is the need of this increasing population? Need of this increasing population is no doubt food, no doubt shelter, and in shelter, in house. First thing we do to build a house is to start a small pumping unit. That pumping unit has to pump a lot of water throughout that house, stay there, or you stay there, or the house is there. So we are just pumping. Why not recharging? If there is policy, if there is a strategy by the householders or by the public that everyone who has to pump the water, he has also to recharge the water. And if there is pumping motor, there should be recharge setup. It's very easy. Nations are doing it. And we can do it only after flush water, which is just after 5-10 minutes, and dust is gone, only contamination in the air or on the surface, they are gone. They are just flushed out. And why the water should go out of house? This is the question in house recharge. And I will show you some slides that, and I picked those slides from the net. If anybody want to see this in-house recharge, you should come and visit my house. Let me share with you that I have almost 4 canal house in village. And I assure you, not a drop of water go outside. I have made a very nice tank inside of the house. All the water after 10-15 minutes starts coming to the, and there are recharging well, that water go to the groundwater. On-farm recharge. Regarding on-farm recharge, yes, we need to go for another strategy, the policy that even very small farmer, like 3-4 acre farmer, 5 acre farmer, he should have 1 acre lying on the downside. He should pick the soil from there, put on roadside, or take out of the farm and have this low-lying 1 acre out of 5 acres. And whenever there is rainfall, let him collect the rainwater in that 1 acre. Use those crops, especially 2 days when there is rainfall. 80% rainfall happens in monsoon when we have the rice crop. So if farmer is wise, why he is crying for shortage of water? If he has 1 acre out of 5 acres, just 1 acre is down, and is collecting rainwater in that 1 acre, he can grow rice crop without additional water. That's irrigation. So this kind of strategies or policies must be there on the farm. That water is not going to be wasted. It's not going to flood. It's not going to damage our properties on the way of rivers. And I will show you some slide what happens when there is rainfall. So if all farmers, they go for this strategy that in every 5 acre, 10 acres, they go for 1 acre, just a down acre, a low-lying acre, and all the water is going in that 1 or 2 acres, and he is growing rice in that. That's not going to save a lot of water, but also going to recharge our ground resource, which is very much required for this country. If there is any drought under the climate change, and we go for 5-year drought, I don't know where we are going to go for food and water. So we need this kind of strategies, that water in ground or groundwater is in such quantum that even 5-year, 6-year, no question is there. So next is conversion of open drains to weir controlled drains. I know I born and I was student when we were facing a kind of waterlogged soil. And I led myself in the class as well outside that we are losing 1 acre in 1 hour due to high water table or waterlogging. So where that waterlogging gone? Because our canal system has been designed only for small cropping intensity, very small. And we have gone to 200% cropping intensity. This is for 70%. And we have gone to 200% cropping intensity. 200% cropping intensity mean 130 acres are being irrigated by the groundwater. So you can see that water lagging is gone. Now the control, flood drains, they are gone. Now, but flood drains are still existing in the same way. If there is rainfall, water goes like anything. It goes very fast to the channels and finally to the river, and there is flood. So my request is that policies and strategies both should work for this part. Policy should be there that we have to convert our flood drains to the weir control drains. After every mile or 2 kilometers, we have a small barrier that whenever there is water, there is orifice in the wall, we should close the orifice and control the weir and let the water stay in the drain. Let the water stay in the drain. Step by step, we should reduce runoff, and this water will go to our groundwater, which is a big storage, which can help us when there's no water, and it will help us for our groundwater recharge. And the same story is for river control recharge. If we don't want to go for barrages or dams, and we don't want to give a gift of electricity, a cheap electricity to our nation, the coming generation. Yes, at least we should have the walls in the rivers, a kind of orifice, weir type walls that let the water go to the next, but we have to store it, backup store in all the rivers. If we are having the backup store, first to own the farm, in the house, then in the rivers, yes, we can play with water, rather the water should play with us, as you will see in the next slides. So first slides, I just picked it. I myself is doing in my house. I proposed in the University of Agriculture Faisalabad. We did it, but at smaller scale. When I went to India, Ludhiana University, I saw a big number of recharging wells. But in Pakistan, no way. I talked to the governments, many governments. This government, the previous government, that let's collect our park, our street water after flush water, and let the water store, even if little is coming out of house or home, we should store somewhere on the way and use it for purpose. Next, please. Now, this is another ways of storing water. So you can see this all is available on it. When our students, young students, young generation, everybody is watching that they are having what not. I don't want to talk about the youth. You can understand what I want to say. They should also look for this kind of facilities or efforts being made by the other nations. And at least if we don't have the brain to go for it, we should at least copy the people. No doubt we are going to be second-hand user, but I think there are a few who should teach the others. This is a message to our teachers, researchers, that why not if we are crying like anything that we are water shortage country, why not we should do this kind of activities? Here is the drains. I was talking about the drains. These are the flood drains. In flood drains, they should be maintained. There should be put barriers. When there's rainfall, let's open the barriers, let the water go, and let the stop water, the tail water, in the barriers of every 1 kilometer or 2 kilometer. Let it go to the groundwater. So this way we are going to increase. We are going to increase our storage, that's groundwater storage. And even we can pump this water by solar activities, used for irrigation and many other activities. So this water in 2 months go where it wants and create floods and everybody's crying, government's crying, people are crying, they're dying, animals are dying. I will show you a similar situation in Germany. When I went there, terrible. Their nations, they have their priorities, how they manage the floods. I will show you next slide. This is Bangkok. This was the 2 slides I presented back in 2006 in irrigation department. There was one seminar in irrigation department, and I presented this Darya Bangkok. They are enjoying this water by boats, and they store it when there is no water by blocking on the upstream and downstream, and making their enjoyment out of water. And this also go for recharging. Whereas we have this scenario in Lahore. I presented this in detail about Ravi, sewage water coming from India, sewage water by the Lahoris, and whatnot, other sources. And this is what we have. And thanks God, I was happy to know that the present government is planning to go for Ravi project. This way, they will recharge groundwater in Lahore, as well as there will be kind of public movement or enjoyment place in Lahore or nearby Lahore. So I'm very happy to know that this Navi project is just going to start. This is how if we don't control water in our house or recharge, if we don't harvest water in on our farms, and all at even a small water is reaching our drains, our roads, our rivers. This we face after every 5 years, 6 years, when there is relatively high rainfall. So we must have this kind of rainwater harvesting facility at home, in park, on roadside, everywhere we can store water, and we can address this floods issues in Pakistan. This is the one of slide when I was in Germany, I visited their flood plains, and they gave me presentation on the flood control. You can see the basin on my left side, 1828. This is the catchment area. This is the watershed. And after 2002, you can see the watershed or basin after development. So this how they are controlling. No doubt they have controlled water in the glass walls. They enjoy. When the flood high water is coming, they enjoy. You can see slide number 1 presentation, slide number 2 flood, number 3 the watershed management, and then the water control, and then the water in the glass. And they told me in the presentation that they take only 8 hours to go for 3-mile walls of glass and to avoid the losses of floods. And after that, they take these glass walls back to store and they enjoy the area. And what you know better than me that what happens, and you have seen in the last slide that when there's flood, what happened. It was same in Germany as well. If you look in the second top slide, but they have managed it. Yes, the good part we did is the control on our rivers, the Villa Dam, Angla Dam, few other dams. But after that, we started fighting. I couldn't understand. When there's water, there's sharing. When there's no water, what kind of sharing? Every time I really don't know. I don't want to comment on that. But this all is sad story that if there is water stores, if there's dams, if there are water storages on the upstream, there will be no water on the down. I feel I have discussed with my colleagues in the Tandojam University and even in the other universities that after storage, since there's as starting more water has been receiving more water than the before these dams. So we should share this kind of data with our colleagues and friends. This is very important that we should increase our surface storage, increase our energy, and go for industry and what's not, especially the food industry. You can see the fruits everywhere in the market, and there is just after 2-3 months, one fruit is gone, other is coming. We must need food processing industries, quality food and quality food products. Let it go to all over globally, all the world, all the countries, and you will see that all the farmers coming up. There's 60-70% farmers, and you cannot imagine that with the decrease of land's resource, what are the situations. So my part is my work. When I got the chance of Vice Chancellor in Arid Agriculture University, and probably God gave me chance to do this activity. I went there. My university, Arid Agriculture University, half of that was a kind of, I don't have a word for that, flooded water, mosquito, hub, even murders. My God, it was submerged out of the university. So when I had a look, I thought, oh my God, probably God has given me this chance to do something for the university and for this area. And next day I started my job. There was 200 acres of farm, unattended farm, no activity. When I asked my professors, colleagues, friends, and even the farm team that what we have at the farm, they said, yes, no water, so what we should do? They said, there's no water. I said, there's a lot of water. They said, no water. So my first activity started was go to farm early in the morning before sunrise and do this activity. First of all, I selected 5 points, and I will show you next slide that how much water I started storing by rainwater harvesting. Then on my campus, you please look at in the slides. This was one of 5th storage on the farm, and then I put fish in all these storages. A lot of fish. I will be sharing with you that when I was school kid, we are used to catch the fish from rice field because I belong to village. There is a big contribution of fish for agriculture to increase the agriculture productivity. The reason is, I will explain you in the next slide. These are the water ponds, water storages on the in the 200 acre of university farm. That they are putting fish in that. As you can see, the size of ABCD, all the storage, and 56 acre feet was there. 56 acre feet. If we use 4-inch water, not by flood, but sprinkler, but dip, this is more than 200 acres water for growing crops. This was the layout. Yes, drip irrigation is very important, but it's important for our pothwar area, it is important for our hilly area, it is important for our sandy area, it is not important for our irrigated areas. I request all the please, yes, if you want to grow some vegetable or some other where we need it very uh, we need it like that we have to grow vegetable and 1 or 2 acres and drip irrigation is there. But even then, I say that there's alternate. I'm going to discuss with you in the next slide. That drip irrigation, sprinkler irrigation, pivot irrigation system. All these systems are meant for either the sandy soils or in the uneven topography soils. We have a lot of that soil and source. So our system must go there. They go for orchards. I'm going to discuss this in the next slide. This is the on-campus rainwater harvesting, which was hello. Hello.
Yes, sir, we are listening you, sir. But there is a voice in backgrounds. All the participants.
Raj, are you with me? Hello. 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 Raj?
Yes, sir, we are listening you, sir.
Okay. I'm just going to finish in 5 minutes.
Yeah, please, sir.
So this is the kind of pond or small reservoir I developed in the heart of Arid Agriculture University, and you can see it was worst place in the university, and now it's the best place in the university. Let's go to potential of rainwater storage in Pothohar. I also went for study. One of our students did probably master or PhD on this activity, but I asked my colleagues to go for this practice. And at the end of this, what was conclusion, that you can see that 13,000 ponds or reservoir can be developed in the Pothohar. And if we harvest all water in the Pothohar, which is probably next to mountain area, is the highest rainfall area. So you can see that we can address irrigation water in Pothohar, we can grow vegetables and orchids. What a kind of fruits in the Pothohar. Every type of fruit can be grown in the Pothohar area next to the mountain. So this is the area where we can control. This is watershed for our rivers. So we can use this water. And I just to tease, not to recommend, there was this amount of water after developing 5 small ponds or reservoirs in the farm of 200 acres of the Arid University. I asked my colleagues to grow rice, and we did it. You can see the rice in Pothohar with the water. So this much amount of water we have, which just is wasted. So I don't recommend the rice and Pothohar, but just I wanted to teach my nearby colleagues, farmers, everybody, that this is what we should do. We should grow what we but we can grow in the area. There's a lot of water, but that water is going to create floods. Now, surface irrigation and flood irrigation. Our farmers, whether they have 5 acre, 10 acre, 25 acre or above, they are using flood irrigation. In irrigated area, as I said, there's no need of drip irrigation. What is the alternate? I'm going to give you that when I started saying about this, that there's no need of drip irrigation, I give the alternate as well, and I'm going to explain. It was my another research area where I spent almost 10 years working on this area. That is bed furrow irrigation system. Pressurized irrigation system, no doubt, drip irrigation, sprinkler, central pivot system. I have seen central pivot system just one next to on the Lahore roadside. When I go to Lahore by motorway, you see the big sprinklers are working on the farm. Okay, if you want to present the people to just as a example of just to awareness, it's all right. But really, what we need for this area is efficient use of water, rainwater harvesting on the farm. This is what I say, and my friends and seniors say, that this is the drip irrigation of irrigated areas. This was the 4-row wheat bed planter developed by the Water Management Research Center, where I was director, and my team, we worked day and night and developed this machine to grow rice, wheat, to replace this flood irrigation. What happened as a result? I again telling my friend and farmers that this technology not only save 50% water, means you can irrigate 2 acres rather than 1 acre, and with 25% increase in the yield. What we need? And if this technology has to take another 25 years, I cannot say as it took for the lesser land developers. So here is the job of extension workers and other colleagues and farmers. Alhamdulillah, I'm getting calls from Islamabad here and there to buy this machine, but this machine should be part of every farmers. Only irrigate and furrow 66 furrow an acre and grow wheat, vegetables, rice, cotton, maize, sugarcane in the crop. So this was, and if you want to further increase water losses on the farm by water courses, this pipe should be part of the bed furrow system. This is very common in Iran. This pipe flow is just put in addition to bed furrow system. There's win-win side. There's no need to go for. And if you really want to go for small farmers, small kind of plot for vegetable, yes, you should have the mobile drip irrigation system. This will develop mobile, because in our setup, consolidation, my God, my land about another village was consolidated. It was about 10 acres in that area. And what they did, they put in probably several pieces rather consolidated. I don't want to go in detail, but this is unfortunate. Then we need kind of mobile unit for small farm. They should take it, irrigate it, and take it back. So these are available with the Agriculture University of Faisalabad. This was another system I developed to replace the drip irrigation. This is perforated pipe. This is small storage tank, and we just attach with the pipe flow. Only thing why I did it, you will say that on the other one hand you are saying that there should be no drip irrigation. On the other hand, you are giving us this technology. This RAI system, ring automatic irrigation system, does not need pressure. It just needs flow of water in pipe. No pressure head is required like in drip irrigation. Water should each year fill this ring and fill this part. And after filling this part, then automatically you will see, probably I put one slide here, it's not here, it will just moist this soil and water will stay there. Automatically water will be coming in these parts. If somebody is interested, he should give me a call, I will help him. Current issues and solutions, where we stand globally. Land resource is going to be very limited. Farmers are, their kids, the coming generation is going to be out of farm. In my village, where there was size of almost 25 acres, now it has gone in 1 acre, 2 acres, 3 acres, and the kids, they are going for labor, and they are in a terrible position. Only, but how we can address this issue? Low productivity issue. Yes, there are solutions, as the other people has done it. Hydroponic agriculture. Hydroponic agriculture, simply a control shed like poultry. You have to control the temperature. There's no land required. You can grow on at the roof of your house. You can grow in anywhere because it doesn't need the land. So you have to grow in the growing media, which is rice straw. I have been using, after a lot of research, in the foreign countries they're using kind of the cocoa material, cocoa top waste material. Next is Biofloc. I asked one of the very senior colleagues working in the zoology, what is Biofloc? He said, I don't know. Biofloc is high density fish farming. And what is aquaponic? Aquaponic is mix of hydroponic and biofloc. That's the aquaponic. Hydroponic 1 acre agriculture gives you at least 40 acre land resource. Its production is equal to 40 acre. 1 acre is go for 40 times. People are saying 50, 60 times. I say 40 times. If you grow 1 acre hydroponic, you can get high quality vegetable, high quality fodder, high quality every type of food. And it is, for example, let me give you tomato example. Advanced farmer in Pakistan, by using tunnels, they are getting only 10 to 12 or maximum 50 tons per acre. Again, please, 10 to 15 tons per acre. This technology in European countries, in China, in other countries, it is giving how much? Can you guess? 400 tons tomato per acre. Now, question, this system is with the Arid Agriculture University for the last 10, 15 years. Handed over by the European, and they couldn't, they went back due to security threat. They handed over to university. When I joined the university and I went there, I was happy to know that there's simple, basic tools in this. So I produced 3 students work for their PhD thesis on this technology. We replace these glasses, we replace automations, we replace its heating system, we replaced its cooling system, we replaced growing media, we replaced many things. Its cost was about 10 millions per acre. And we came about 1 million. 1 million to maximum 2 million if you want to go for automation. So, and still I'm working. Next is, this is the part of hydroponic. This is Biofloc. Biofloc is kind of another technology. High density fish farming. Very common in India. Very common in other developing countries, but in Pakistan, only 1 or 2 centers. One in University of Agriculture, Faisalabad. I was happy to know that one of our colleagues has started this, but it's a kind of a new thing in Pakistan. I said that when I was student, I was used to catch fish from rice fields. This is the same thing. What they have done, what the fish need high rate of oxygen when it is in high density. So aeration is very important. So they put the blower in the system. Please go in the net, look for hydroponic, look for the biofloc. They have given in detail how to build it. I have my biofloc system. I have my poultry system. On the top of that, poultry waste go for fish and fish water. That is my next question. Fish water, biofloc water. That is biofloc water. Fish water is ammonia, and which is converted to nitrate. Which is converted to nitrate, and nitrate is required for crops. So fish water, waste water is very much required for hydro. This is the story of aquaponics. So fish water gives you nitrate, and what we add, microbes and worms and everything and food, that is the need of our crops, not only for tomato, but all crops. So this is smart agriculture, or kind of food agriculture, for which we can raise fish by what I said, this biofloc, and this water should go for growing vegetable. And what happens? I was talking about hydroponic. Hydroponic, 1 acre needs about 1 million rupees input, and it gives you return about same amount, 10 million every year. If you want to reduce that, you should blend it or use the biofloc, and use the biofloc water for growing hydroponic crops. Then your input cost is gone 25%. So this is the major concern. This is my harvested water. If somebody is interested to join me in my village, my farm, you will see the fish, you will see the kind of hydroponic, you will see that how I'm using, blending this poultry waste for fish and fish wastewater using for hydroponic, and growing very nice vegetables. I'm sorry that I could not put I could not put movies to show you my work because it was overloaded, and I could not save it. But inshallah, next time I will join you in center, and we will inshallah present. Before you leave, if I could on it, please. This is also a part of my work, please, and it's very much required for this country.